Right.
So we're now going to move to a second talk, also related to BioDynaMo, and this is from Damla, who I've seen is already with us. So Damla, please put your video on, share your screen, and take it away.
Hello, I'm sharing my screen. Okay, can you see it?
Oh, looks good. Thanks, Damla.
Okay, great. So, hello everybody, I'm Damla Gözük, and today I'm going to present and explain you our project here at CERN in the BioDynaMo team. So, what is BioDynaMo? BioDynaMo is an open source, high performance and modular agent-based simulation platform. It's rooted in C++. It has 5 system properties. It's agent-based, general purpose platform. It's a large-scale model support. It's easily programmable, and its quality is assured. Now I will briefly talk about the neuroscience use case of BioDynaMo. The example illustrates the use of BioDynaMo to model neural growth of pyramidal cells using chemical cues. And the video and the figure shows the comparison between the real pyramidal cell morphology and its mass model by using the BioDynaMo. My work in BioDynaMo mainly consists of benchmarking. Benchmarking is highly important because it allows us to test the code performance and monitor the effect of the changes. It allows us to observe the project speed, memory usage, and hardware efficiency. The root system is created at CERN and is used for data analysis. The root team has its own benchmarking system called Root Bench. It's categorized into 3 categories: performance monitoring primitives, visualization features, and data storage. Google Benchmark Library has a significant role that provides multi-threading and custom report generation. It has an extensive C++ library. BioDynaMo team was inspired by the Root Bench. We visualize our data with Grafana. It allows us to collect data from numerous sources and share data between all the team members. Grafana is a general purpose dashboard and graph composer. It provides many ways to visualize time series metrics, and it supports database backends such as InfluxDB. So conclusions and future work. In the beginning, we had a problem deploying the project to MacBook's new M1 chip, which I'm using. After much research and communications, we fixed the incompatibility of root so that it can run on the newest Apple laptops. For future works, performance improvements in terms of CPU and GPU are needed. Track slowdowns, speedups, memory increase, decrease between versions, and assign performance numbers to a user's machine in the form of BDM marks. So thanks to everyone for listening to my presentation. Here are some links to our project, papers, and webpage if you want to check out. There is always room for improvement. So if you would like to contribute to bug fixes and etc., please feel free to visit the webpage and follow the guidelines. Thank you.
Thank you, Dan.